This is the Samsung 170MP, and it might just be the perfect flat panel for all your retro computing needs. I'm Matt D'Amico, and welcome to episode 79 of Retro Bits. Back in episode 3 of Thrifts and Donations, I was perusing the not insignificant number of LCD panels that my local restore had on their shelves when one in particular caught my eye. The first thing that grabbed my attention was the SyncMaster model name. The second was the nice variety of inputs found on the back. It was only $15, so I took a chance and brought the display home with me that day. Let's take a quick peek at the specifications in the service manual. Ooh, confidential. Well, I won't tell if you won't. Anyway, what we have here is a 17-inch TFT panel with a native resolution of 1280 by 1024. Of interest is that the documentation claims a supported minimum horizontal frequency of 30 kHz. Now, I had a quick look on my phone before deciding to purchase, and what I found on 15kHz.net seemed to contradict that claim. This site is a useful resource that lists brands and models of both CRT and LCD displays with support for 15 kHz RGB. It caters to the Amiga, but if a display is listed here, it's likely that it will work for a lot of other systems as well. And the SyncMaster 170MP is here, despite what it says in the service manual. There are a number of different signal formats when it comes to RGB video, mostly involving different types of synchronization. Taking another look at the service manual, we can see that the display supports separate horizontal and vertical sync. Most VGA-type displays use this and only this format. The Samsung, however, also seems to support composite sync as well as sync on green. If true, this should give it nearly universal support for retro computers and game consoles using 240p RGB and above. Before we get to testing the SyncMaster, let's take a quick look at the CNET review for this model from way back in October of 2000. Right off the bat, they claim that the picture quality is stunning. Okay, so far so good. Here, CNET calls the Samsung a hands-down bargain and praises its low price of $1,600. Come again? That's over $2,700 in today's currency. Holy moly! They go on to say it doubles as a standalone television despite lacking digital input, which is worth something, I guess. I must have forgotten how expensive flat panels were when they first started to become mainstream because that seems like a lot to me. Alright, so here we are with the Samsung SyncMaster 170MP. And the very first thing to note about this monitor is that it is absolutely filthy. Here, let me show you what I mean. Yeah, clearly it's been sitting before it was donated, probably after it was donated for quite some time. So there is a thin layer of dust along the top here and everything else is kind of disgusting. But more importantly, around the back is where it is the worst. Yeah, that's super gross there. I don't even want to touch that. So the first thing I'm going to do is grab the vacuum cleaner and just get all of the big particles of loose dust off of this thing. All right, with that done, I'm just going to take some glass cleaner and a paper towel and see what I can do. Well, we're getting there. It's pretty gross, but a little bit more elbow grease and I'll wrap this up. All right, and there we go. A lot better than it was. It's not perfect, but it will do for today. So first impressions of the SyncMaster 170MP. Well, I'm going to be doing a lot of comparisons of this display to the Dell flat panels that I usually use on this channel. They are of roughly the same era, so and roughly the same capabilities as well. So throughout this video, I'll be making comparisons. And the first comparison I want to make is the size of the bezel here. Compared to the Dell flat panels of this era, it is much, much wider. I'm not sure why they designed it that way, but that stands out right away, is that it has a huge front face and a much larger bezel. Now, in terms of price, well, I paid $15 for this. That's not 10 times cheaper than this was originally. That's 100 times cheaper than this monitor was originally. So we need to figure out why this monitor was so expensive when it was new. Taking a look here at the controls, these are relatively nice. They're placed right on the front and they're labeled well. So we have easy access to volume and channel, power, menu, and source here, and it has little LEDs for each of the different source inputs, which is really nice. This is a convenient way to access all of those features without having to dig around in a menu. So I like that about this already. And you can kind of see here that there are some speakers built in, which is also a nice feature. This is clearly meant to be used as a TV as well as a monitor. And one other interesting feature is that unlike the Dell where it has a stand that can be raised or lowered, this one does not. But the stand does have an interesting feature where it will recline. So you can tilt the monitor backwards and forwards, and that might help you see the speakers a little bit better down there as well. Now let me demonstrate that tilt feature again with the full monitor in view. It goes back about 15 degrees, but there's a button you can press on the base of the stand, and if you press that button, it will recline completely flat, although I don't think it'll stand up on its own. So you have quite a range of adjustability there, which is kind of neat. Now there's one more thing I wanted to say about the aesthetic of this monitor, and that's that this big silver bezel, I don't find this to be attractive at all. It does look stylish on its own, but it doesn't work well with any of the systems I plan to plug this into, whether they're a beige Amiga or a black modern case or anything like that. This silver, maybe it is a product of its time, but it doesn't work with any of the retro computers that I plan to plug into it. So not a huge fan of the styling compared to, again, the black bezel of the Dell monitors that I do use. Taking a quick look at the label, we have the model name 170MP as on the front, and the model code is GD17N, where the N is for NTSC. There's also a PAL/CCAM model available for the overseas market. Down here we can see that it was manufactured in March of 2003, and it was made in Korea as you would expect from a Samsung. Alright, so let's take a look at the back panel inputs here, and the first thing I wanted to point out is that unlike the Dells, it doesn't take an industry standard 3-prong power adapter. It needs its own proprietary 14-volt DC adapter, and the monitor didn't come with its own. So I did have to pick up a replacement adapter. I think I bought this on eBay. It wasn't a lot of money, it was less than $20, but it does obviously eat into the cost savings of buying this from a thrift store in the first place. So I've got the replacement power adapter there, and let's take a look at some of these other inputs. Alright, so from left to right, we've got the 14-volt DC input, we've got the HD15 VGA and RGB input, we've got S-Video and composite left-right audio. We have a stereo 1/8 inch input, it looks like, and also that could be a line out, it doesn't actually say. And it looks like we also have an 1/8 inch headphone jack, probably amplified there. And last but not least, we have a 75 ohm RF input here. So a fairly comprehensive set of inputs for a lot of different devices. One thing that is missing that the Dell has is component input, which is not present here. And also this doesn't appear to have a built-in USB hub like the Dell does. But otherwise, a pretty comprehensive set of inputs. One final thing on the back is that we have 4 holes here for a standard VESA mount if you wanted to mount this on an arm and not use the built-in stand. All right, I've got the power adapter connected and plugged in, and let's hit the on button. Promising, we've got a green band. And a Samsung logo. Excellent. Oh, that's really dim though. All right, first impression is switching between sources is very slow. It takes a good 5 seconds when you press the button for it to switch sources. And the other thing that I found right off the bat is that the menu button doesn't seem to work. I've pressed it, but no menu is forthcoming. Yeah, I think we have a problem here. The speakers are emitting a bit of a hiss even when there's no audio connected to the video input here, and the menu isn't coming up. So let me get something connected and we can see if we're getting any kind of display at all, or if this thing is just DOA, because the menu isn't coming up. The only thing I saw was the little Samsung logo bouncing around. All right, I've got my C64 hooked up with S-Video to the monitor. S-Video is V1 on the back, and we've got V1 selected. One thing I noticed is that when you power cycle the monitor, it does remember the last input that you had selected, which is something you would expect from a $1,500 display. Let's see if we get anything. And that looks like a big fat nothing. The power is on, we're on the right input, and there is nothing on the screen. Bummer. Now, just to make sure, I also hooked up the Commodore to the composite input, and if I switch to the other V2 input, you can see it says video here in the upper right hand corner for just a brief moment, but there's still nothing on the screen at all. And if I switch to the RF input, we do get snow, and the channel select buttons do work, so I can page through the channels that aren't there. But it doesn't look like I'm able to get anything on either S-Video or composite. All right, this is really weird. I've got the monitor powered on and on the PC input, and you can see that the screen is on and the Samsung logo is being displayed. The Mr. FPGA is here, and it's not turned on, and I haven't yet connected the other end of the cable. As soon as I plug in the VGA cable to the monitor, it shuts itself off and won't come back on. It is effectively dead as long as the PC cable is plugged in. Oh, no, it came back on, but it shut itself right back off. It will not stay on when anything is plugged in to the VGA port, even if it's not turned on. So there's definitely some weirdness going on with this thing, and I think the next thing to do is open it up and see if there's anything obviously wrong inside it. To disassemble, we first have to start with these two screws here and here. Next, we have to remove these 5 screws from the back panel. Now, if I'm honest, I'm not exactly sure what I'm hoping to find by taking this apart. It would be nice if there was something obvious, like a dry, broken solder joint, or perhaps a wiring harness that is partially disconnected or something that's loose inside. I would also like to see if there are any electrolytic capacitors that are bulging, leaking, or anything like that, but we won't know till we get inside this thing. Now, per the service manual, we're supposed to insert our plastic spudger here, and the back panel should separate from the front panel if we pull up on it. I don't want to break anything, but let's give this a try. Oh, there we go. That was actually really easy. Let me do the other side. And just like that, the whole back panel comes off. So what it looks like is we have our LCD panel behind this shield here, and then the control electronics behind this shield here, and there's a lot of screws to remove that, and it's connected by this cable down here to the front panel PCB. So I'm going to start by removing the control board and seeing what that looks like. Looks like we need to disconnect the cables that go to the stereo speakers. Is this a lift up or push down sort of situation here? Push down. Go. There we go. All right, so here we have the main board for the system, and we have a number of wiring harnesses that are connected here, but it looks like for the most part, they're all glued into place, so it doesn't look like any of them have come loose. So in addition to that, we have a number of electrolytic capacitors. Actually, there's quite a few, dozens of them. We've got a whole bunch of surface mount capacitors in various sizes here, here, and here, and then a number of electrolytic through-hole capacitors as well. Let me get you close up in on that. Yeah, so hopefully that will help you see. There's no leakage that I can see on the board underneath any of these capacitors. There's no bulging. So what I'm going to have to do is grab my capacitor tester, and I'll start by testing all of them in circuit and see if anything is obviously bad. Now, before I disassemble anything any further, I want to run through some of the diagnostics from the service manual just to check voltages. So I'm going to plug in the power supply now. And the first thing that we want to check is that there is 5 volts on pin 4 of IC 101, which is right there. So 1, 2, 3, 4. Okay, we've got 5 volts there. The next thing we want to check is that 2.5 volts appear on pin 2 of IC 109 and IC 104. So there's pin 2 of IC 109. Yep, that's close to 2.5 volts. And IC 104 is over here, so let's check pin 2 of that. Okay, 2.5 volts, so those are both good. And now we want to see if 3.3 volts appears on pin 3 of IC 103. Yep, that looks good too. Okay, so we've got basic voltage regulation here. No problems there. Now I spied this big capacitor here on what I assume is the high voltage power supply section. It probably drives the backlighting for this display. Now I'm not sure why there's so many wires on this wiring harness coming to or from this board here. This isn't a full matrix display, I'm sure that's not the case, so it's probably edge lit. But there is this one capacitor here and I wanted to test that first before we do anything else. Okay, so it can't measure this capacitor while it's in circuit. That or the capacitor is bad. So the only way I can test this is to remove it from the board. So that's what I'm going to do. All right, I've extracted the board. I've got it in my stand here. Here's the capacitor we want to remove. And I've got my desoldering gun. Let's make this happen. Oh, it's glued in there just a little bit. No problem. I'll just pry it off. All right, there we go. All right, now that we've got the cap extracted, let's test it again out of circuit. All right, we've got 356.6 microfarads, and this is a 470 microfarad cap, so it's a little bit out of spec there, even given the tolerances. The thing that I'm not happy about there is the equivalent series resistance is 2.9 ohms, and a cap of this size should have an ESR of less than half of an ohm. So it's safe to say this cap is pretty tired, pretty bad. It would be a good idea to replace this, but I'm not saying that this is a smoking gun and it's not responsible for causing everything else to fail. But it doesn't hurt, so let's replace this one and then go from there. I had a look around my spare parts kit for a suitable replacement, and all I could find new was this 470 at 16 volt part, but I had a look at the service manual and it does indeed call for a 25 volt piece, which I did not have on hand. So it's now a few days later, and I'm now the proud owner of a set of parts from Amazon. It, again, is always cheaper to buy, in this case, 1,000 pieces than it is to buy 5. So now I have the part I need plus lots of others. So these aren't really particularly high quality. They're not Panasonic or Nichicon or anything like that. But for this purpose, it should get the job done, and it wasn't expensive. Right, so we're done replacing the cap here, but I have no illusions that this one cap is going to be responsible for the problems we saw with the inputs not working or the monitor shutting itself off. This board is definitely just the inverter circuit for the backlight, and it may be partially responsible for why the image was so washed out or so dim. Maybe it'll be brighter now, but we still have to look further afield to see what else is wrong with this display. So let's do that now. All right, so here once again is the main PCB for the control board, and I've removed it from its mounting. Now, one thing to notice about this board is there are 1, 2, 3, 4, 5, 6 through-hole electrolytic caps here, and I'm going to test those next. There are also more than 50, it looks like, surface mount electrolytics, and then there's literally hundreds of tiny, 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 like tantalum surface mounts. Things that I'm not going to mess with. So let's start with the obvious, easy things first, and we'll test these out here. So once again, I've got my ESR meter here, and all we have to do is connect the 2 probes to each one of the caps, one at a time, and test. Now, what we're looking for is a double chime. The double beep means that the cap is generally good. A single beep might be a problem, and no beep at all, we'll see. So let's start with this one. Okay, so that double beep usually means that we're good. The ESR is well within limits. It couldn't measure the cap, but just because it's in circuit, but we'll keep moving on. Okay, that one provided a capacitance measurement and ESR looks good. We got the double ping, which is great. Okay, we've got a measurement and a low ESR, double ping, good. Okay, that single beep is bad, and if you look at the ESR, 21.6 ohms. That's definitely not good. So we're gonna have to desolder this cap, remove it from the circuit, and test it again. Another single beep, and 6 ohm ESR, also too high. And one last cap to test. Okay, ESR over 40. That's definitely bad. That sound was not a good sound. So I'm going to have to remove these 3 capacitors, and then we'll test these out of circuit and see if any of these are bad. All right, all 3 of the caps we removed are 470 at 16 volts, so let's test them all out of circuit now and see what we've got. Okay, over 40 ESR once again, and it says it's in circuit leaky even though it's not in circuit, so this one's not even testing well out of circuit. Let's try the second one. Okay, ESR of 5.1 ohms, in circuit leaky, also bad. and 19.5 ohms, also bad. So none of these three caps survived. Looks like we may have found our smoking gun here. Let me replace these and then see what we've got. Sitrep, still broken. After replacing these three capacitors, I tried powering it back up with everything connected, and the green light came on, but I was unable to select from an input or pull up the menu or do anything else. So we're still not there. And I suspect it's because it wasn't just these three capacitors that were bad. There are all of these other surface mount electrolytics, and a lot of them in this general area test out poorly. Let me show you what I mean. If I just grab any one of them here, like this one. See, ESR over 40 gives you the bad sound. Try this one here. ESR over 40 gives you the bad sound. So I've tried a lot of them in this area and they all seem to fail. But if I try one in another area, let's just try this one over here. So that's good. And I'm just gonna have to go through every single one of these and write down which ones are bad and see how many bad ones we've got and see if it's even worth ordering the parts and trying to fix this. Because I'm not convinced that that's the only thing wrong with this, but you know, there are enough bad capacitors that it's probably worth changing some of them out to see if we can get this thing working or not. So that's what I'm gonna do. And here's the result. All of these tested bad. That's 40 electrolytic capacitors, surface mount caps that I'd have to change just to have a chance at saving this display. So now the question is it really worth it? Once again, here's the service manual, this time listing the parts on the main PCB. Here are all of the capacitors. Pages and pages and pages of them. A lot of them are ceramic and are probably fine, but there's still quite a lot of aluminum electrolytics, and from what I can tell, most, if not all of them, will need to be replaced. Here's a spreadsheet of the caps that tested bad and their specs from the manual. I priced out the ones I could easily find on DigiKey, but some weren't stocked. Overall, it wouldn't cost much to buy replacements. The real investment is going to be time. I had really hoped to test out the monitor in this video on various systems like the Amiga, Atari ST, and Mr. FPGA to see how good the 15 kHz RGB support is. I was also planning to use it in the next episode, which will feature a system that uses 15, 24, and 31 kHz video modes. 3 guesses which one I'm talking about. I needed another solution quick, so instead I shifted gears and built this. The project is called GBS Control, and it's a high-performance RGB upscaler and downscaler that uses a commodity TVIA TrueView video display processor coupled with an ESP8266 microcontroller and Wi-Fi module. With this setup, I should be able to use any vintage RGB computer or console with my existing display and video capture device. All right, I think that's about as far as we can go today. So, what lessons did we learn? Well, first of all, if you see a Samsung 170MP come up for sale, I would avoid it. Chances are, even if it works now, that the capacitors will fail in the future and then you'll be left with a dead monitor. If you're looking for a project, that's one thing, but otherwise, I would say avoid it. And that brings me to my second point. Not every retro story has a happy ending. You can't fix every piece of old gear. It's simply not worth the time investment. I have so many other projects on the pile that need to be serviced. That Amiga CD32 needs to be recapped. I've got a Sega Game Gear that needs to be serviced. That Amiga 1000 has shipping damage and won't boot. Dozens of other things that are more worthwhile of the time investment than fixing this $15 thrift store monitor. Now, I could go and replace all the surface mount caps. Some of them are in really hard to reach places. It may take 10 or 12 hours to do it. And even after that, the monitor still might not work. There may be other problems with it. So is it really worth the time investment? So I leave this up to you, the viewer. Do you want to see a part 2? Is it worth fixing this monitor? Let me know in the comments what you think. Thanks for watching.